Section 6.4, Logarithmic Functions. All right, we first need to talk about what a logarithm is, okay? There are several different types of logarithms. We're going to begin with something called a common logarithm. So the first bullet point there says, what is log of 100? Okay, so it's okay if you've never seen logarithms before. When I was in school, I actually did not learn them. Okay, so you may have never seen these before. Okay, so as some help here to kind of start understanding these things, let's take a look at a calculator. Okay, if you look at your calculator, there are two logarithm buttons on your calculator. The first one is LOG. If you look where my arrow is, I'm circling the LOG button. And the other one is LN. Okay, that's a logarithm button as well. Okay, so let me write that on here. All right, so your calculator has two logarithm buttons. Okay, so let me put two logarithm buttons on your calculator. Okay, and so that's LOG and there's LN. Okay, so these are the two buttons. Okay, they do different things. Okay, so don't think that since they're both logarithm buttons that they do the same thing. They do not. There is a difference between the two buttons. Okay, so if you notice, I'm asking here about the log LOG of 100. So we're going to figure this out with the calculator, okay? And since it's LOG and not LN, we're going to use the LOG button. Okay, so when I hit that, log comes up, and now I need to take the number, punch that in, close the parentheses, and I get an answer of 2. Okay, so the answer here is 2. Okay, so the log of 100 is equal to 2. Okay, I'm going to come back in just a second and talk about what this means, okay? But before I do that, I want to point out, had we used the LN button instead, okay, and we did LN of 100, we would get a totally different answer. Okay, so again, they do not do the same thing. Okay, keep that in mind. Okay, all right, so let's talk about why the log of 100 is 2. Okay, well, like I said, there's all different types of logarithms. Okay, I'm going to jump to page 2 because I have different logarithms on that page. So I'm going to scroll through some of the logarithms you're going to see in example 2. And each of these, if you look, they each have this tiny number written down. Okay, and even this last one. Okay, they each have this little subscript there, and that is missing from the logarithm that we have here. Okay, so when you see these little tiny numbers, okay, this is called the base of your logarithm. Okay, so this is a base 2 logarithm. Part B has a base 4 logarithm. In part C, there's a base 1/2 logarithm, and so on. Okay, so that's why there's so many different types of logarithms, because any positive number can be your base, okay, except for 1. And so when we come back to log of 100, we do not see that tiny little number there, okay? So the reason for that is when you are working with LOG and there's no base given, okay, it is understood to be 10, okay? When you see plain old LOG and there's no subscript, it's understood to be a base 10 logarithm, okay? That is what a common logarithm is, okay? So when we see common logarithm, this just means that we have a base 10 logarithm, okay? And on the calculator, you should be using LOG. Okay, going back to the calculator, okay, basically the log button is for base 10. LN, which is called a natural log, it is for a different base, and we'll get to that a little later. Okay, LOG cannot be used for base 2 or base 4 or base 5 or whatever. LOG can only be used for base 10. Okay, so your calculator has two buttons, one for base 10, and we'll talk about what the base of ln is when we get there. Okay. All right, so we've established that if you see log, okay, the base is understood to be 10. You can write it in like I did if that helps you, okay? The reason that the answer here is 2 is because if you take the base and raise it to this power, meaning if I do 10 squared, I'm going to get this number, okay? So basically the answer here, 2, is the number I have to raise the base to, which is 10. 10 to what power is going to give me the bigger number, 100. Okay, make sure you understand this arrow thing I just drew. Okay, this is the way any logarithm works. Okay, if you take it, the base, and raise it to this number, you're going to get this number. Okay. All right, so let's keep going here. Okay, so it says in the second bullet point, it says logarithms with base 10 are called common logarithms. Okay, and what I just said, basically log x, which is understood to be log base 10 of x, is the power that 10 must be raised to in order to get x. Okay, all right. In the box, it's just summarizing what I've just told you. If you see a statement like this, log base 10 of x equals y, you may see it, or more commonly, you're going to see it without the base written. So if you see a statement like log x equals y, that just means this, okay, that if you take the base, which is 10, and you raise it to the y power, you're going to get x, okay? So these logarithmic statements are equivalent to 10 to the y power equals x, okay? The arrow thing is super, super helpful for logarithms, okay? All right, so something that's good to know, right here, it says the functions f of x is equal to 10 to the x power, which is an exponential function, and then g of x, which is log base 10 of x. This is a logarithmic function. They are inverse functions, okay? So again, if you see f of x is equal to 10 to the x, and then you look at, this is an exponential function. If you look at the logarithmic function of the same base, okay, these are going to be inverse functions. They undo each other, okay? All right, so let's do some practice with common logarithms here. In example 1, it says find the exact value of each logarithm. Then change each logarithmic statement to an equivalent statement involving an exponent. Okay, so if you look at what I have here, there's two columns. There's a logarithmic form, and then there's an exponential form. So we have, I think we have 4 different logarithms, and we are going to have to give a number as the answer. Okay, so each one of these is going to be log of a number equals. You're going to have to figure out the number that it's equal to. And this is the logarithmic form because it's going to actually have log in it. And in the exponential form, I'll show you what's going to go in that blank. We're basically, the exponential form, those answers will not have a logarithm in them. We're basically using the exponential form to explain the logarithmic form. Okay, so that might be a little confusing. So just watch. Let's do the first one. Okay, so basically, when you see this log of 10,000, okay, the answer is going to be some number. We've got to figure out which number it is, okay? So remember what you're going to do. You're going to look at this and you're going to say, okay, my base is 10. 10 to what power is going to give me 10,000, okay? Well, 10 to the first power is 10. 10 to the second power is 10 times 10, that's 100. 10 to the third power is 10 times 10 times 10, that's 1,000. And 10 to the fourth power is 10 times 10 times 10 times 10. That's 10,000. Okay, so the answer here is 4. Because if you take the base, which is 10, and raise it to the fourth power, you're going to get 10,000. Okay, so the answer to the logarithm is 4. As far as the exponential form goes, we're going to rewrite this statement without a logarithm. Okay, we're basically explaining ourselves. If we take the base and raise it to the fourth power, we're going to get 10,000. Okay, so this is saying the same thing that the logarithm does, but there's no logarithm involved in the equation. Okay, let's try another one. Okay, log of 0.01. Okay, again, that's going to be a number. Okay, so again, the base is understood to be 10. 10 to what power is going to give you 0.01? Okay, well, we've already written down some of the powers of 10. Notice that positive powers do not work. Okay, we're actually wanting to get a decimal as the answer here. Okay, so if we try negative powers, watch what happens. Okay, 10 to the negative 1 power, that's going to be 1 over 10 to the first power. Okay, remember how we learned how to get rid of a negative exponent. Okay, this is going to be 1/10, and 1/10 is 0.1. Okay, so we're getting there. Okay, it's going to be a negative answer. Okay, if we did 10 to the negative 2, that's 1 over 10 to the negative 2, change the sign of the exponent. So it's going to be 1 over 100. Hang on a second. It's going to be 1 over 100. And that's giving us the number that we desire. Okay, this is 0.01. Okay, so the answer here is -2. That's the answer to the logarithm. Okay, you could check yourself on the calculator on both of these that we've done. Okay, log of 10,000, that's 4. Log of 0.01, that's -2. Okay, so yes, you can do these on the calculator, but you really should understand what a logarithm is. Okay, all right, so -2 is the answer here. Okay, if we had to translate this statement into exponential form, just state what we did. If you take the base and raise it to the -2 power, you're going to get 0.01. Okay, all right, part C, the log of 1/10. Okay, what is that going to equal? Well, we just did it. Okay, when we were writing out powers on the side. Okay, if you take 10 and raise it to the -1 power, you're going to get 1 over 10. Okay, which is the same thing in decimal form as 0.1. Okay, so the answer here is -1. Okay, because if you take the base, okay, if you take the base, which is 10, and raise it to the -1 power, you get 1/10. Okay, so let me write that down. In exponential form, 10 to the -1 is equal to 1/10. Okay, all right, part D, log of the square root of 10. Okay, this is a tricky one. Okay, again, it's working the same way. If you have base 10, the base is understood to be 10, 10 to what power is going to give you the square root of 10? Okay, so 10 to what power is going to give you the square root of 10? Okay, you may not know this, okay, but I'm going to tell you right now. Okay, if you see something with a square root, that is the 1/2 power. Okay, so let me go write this up here. Okay, if you see a square root, that is the 1/2 power. If you see a cubed root, that is the 1/3 power. If you see a fourth root, that is the 1/4 power, and hopefully you get the idea here. Okay, a fifth root is going to be a 1/5 power. Okay, so if I'm down here and I'm talking about the square root of 10, the square root of 10 is equal to 10 to the 1/2 power. Okay, because of that square root, it is taking the square root of something is the same thing as raising it to the 1/2 power. Okay, so the answer here is going to be 1/2. Okay, because if you take 10, the base, and raise it to the 1/2 power, that's the same thing as taking the square root of 10. Okay, so that is tricky, but I'm showing you now because when we get to the next section, you're going to see a lot of different roots, and you're going to have to convert between the radical form or the root form and the power. Okay, so make sure you understand that. All right, so basically, these are some examples of common logarithms. Okay, again, you can have any positive number except one be your base. And throughout the rest of this section, we will encounter the different types of logarithms. Okay. All right, before moving on from common logarithms, I want to introduce you to some of the properties of common logarithms. Okay, again, common logarithm just means base 10. All right, so what is the log of 1? Okay, well, again, you could pop this in the calculator. The log of 1 is 0, okay, but again, try to understand why. Okay, if I have the log of 1 equals 0, the reason that is because if you take the base, which is 10, raise it to the 0 power, you're going to get 1. Anything to the 0 power is 1. Okay, so I'm going to put because right there. Okay. All right, moving on. What is log of 10? Okay. Again, you're trying to analyze this. This is log base 10. If I take the base, let me write this out like this. So we're trying to calculate log of 10. Okay. If we take the base, what power do we have to raise it to get this number? Okay. So basically 10 to what power is going to give me 10? Okay, well that answer is 1. Okay, so this is going to be 1 because again, if you take the base and raise it to the first power, you're going to get this number 10. Okay, you can check yourself on the calculator. Log of 10 is 10. Or sorry, log of 10 is 1. All right, moving on. What is the log of 10 to the x? Okay, so now we've got a variable involved. Okay, that's okay. It's still going to work the same way. Okay, so you've got log of 10 to the x. Okay, we're trying to figure out what this equals. Okay, again, if I take the base, what power do I need to raise it to get this quantity? Okay, so 10 to what power is going to give me 10 to the x? Well, the only way this can be equal is if, they have the same base, the exponents have to match. Okay, so you need to have an x right here. Okay, so the answer here is x. Okay, remember I told you guys that log base 10 and 10 to the x are inverses of each other. So if you have log and 10 side by side, nothing's in between them, they're going to cancel and just leave you with x. Okay. This may come with a number. Keep in mind, if I had the log of 10 to the 7th, okay, the log and the 10 are side by side, so they would cancel out and leave you with 7. Okay, so you can use that property with numbers. All right, one more property, okay, very similar to the one we just did. If you take 10 and raise it to the log base 10 power of the log of x, 10 raised to the log of x power. This one's a little more difficult to visualize with the arrows, but keep in mind what I just said. Okay, if you have 10 and log side by side, they're going to cancel out and leave you with just x. Okay, keep in mind if you had something like this, if I had 10 raised to the 2 times log of x, then they would not cancel out because they're not side by side anymore. The 2 is in between. Okay, they have to be side by side, touching essentially, for them to cancel. Okay, so 10 raised to the log of x power is going to give you x. So as an example of this, if I had 10 raised to the log of 7, okay, that would just, the 10 and the log would cancel and give me 7. Okay, and again, all this stuff, a lot of it you can do on the calculator. If I had 10 and I raised it to the log of 7 power, okay, you do end up with 7. Okay, all right, so we're going to move on to bases other than 10, okay, but a lot of the stuff that you've learned here will apply to those bases as well.